Welcome, everyone. I'm Penny Lewis, the Executive Director of the Ecological Landscape Alliance, and I'll be the moderator for today's webinar, Regenerative Design: How Living in Agreement with Nature Helps Organizations Thrive. This is part of the Focus on Sustainability webinar series developed by a group of organizations known for their quality ecological education. By collaborating on these webinars, we expand the reach of our programs to a broader audience. In case you're not familiar with our organizations, they're largely nonprofit and volunteer groups in the United States. Our Focus on Sustainability partners are the Ecological Landscape Alliance, the Chesapeake Conservation Landscaping Council, Deep Roots Kansas City, Rescape California, and the American Public Gardens Association. And now I'd like to introduce our presenter, Claude Stephens. Claude is the facilitator of outreach and regenerative design at Bernheim Arboretum and Research Forest in Clermont, Kentucky. He is also the director of the Children at Play Network, which is an ongoing project in Bernheim focused on working regionally to re-envision the landscapes for children's play. Claude has more than 35 years of experience working in museums and environmentally focused organizations. He has been at Bernheim for 21 of those years. Claude's academic background is in evolutionary ecology and biology, which continues to frame his approach to how humans might build deeper and healthier relationships with the natural world. Welcome, Claude.
Thank you, Penny. I'm glad to be here. It's a little interesting to be sitting here in Louisville, Kentucky on a desk looking out at a screen and knowing that I'm talking to people, but I can't see you. So I would like to be able to be in person, but these are those days. So I want to talk a little bit about the title slide here, regenerative design, and my specific title, Facilitator of Outreach and Regenerative Design, because I think words have importance. So I've done a lot of different things, but currently as the Facilitator of Outreach and Regenerative Design, I focus on building relationships and networks. And relationships can't be directed. So I'm not a director of those things, I'm a facilitator of those things. Today, I want to talk a little bit about where do we put the stone? And by that, I mean, where do we focus our attention, our energies, our design, those kinds of things? Because everything that we do is actually part of something larger. Whether we acknowledge that or not is sometimes up for debate. So are we attached to things that are close to us? Does that extend beyond the borders of our organizations? Are we part of a bigger landscape? So on the right-hand side over there where that arrow is where those earlier photographs were. Everything is connected. And when we think about regenerative design, that's absolutely critical to the way we think about our projects. I also want to point out down here in the lower left of the screen, there's a bunch of disturbed dirt. We're talking about how we respond to our planet, and our planet is responding to us. So this 400,000 plus project down there in the lower left is a new spillway project on a 32-acre lake at Bernheim. We would not be doing that project unless the state had asked us to do that, and the state is asking us to do that because we're in a climate change. So this lake used to have a spillway right over here that was sufficient for draining the lake during heavy floods, very short durations of rain, but that's changing. So we're getting more rain and less time, and so we are recalculating things like 100-year storm loads and those things. So that's a direct cost. That $400,000 is a cost to climate change. So I want to talk today a little bit about how systems are nested from the microsystem to the mesosystem to the exosystem to the macro system, and then how all of those things extend over time, the chronos system, because we often think about our work in the immediacy of our work, but we have to remember that the things that we do have lasting implications on our planet. So let's look at that time that we've been here. Not very long. So 4,500 million years ago is more or less the beginning of life on this planet, which is even older. And our time on that planet is almost nothing compared to geologic time. So let's take a look at where we are right there. We're kind of at that very end of a very long time spectrum. I want to go back 10,000 years because 10,000 years ago is approximately when things began to shift dramatically. So 10,000 years ago, give or take 1,000 here or there, is the beginning of agriculture. Now, prior to that time period, mostly we were tribal, we were moving from place to place, we were living within the limits of our ecologies, and our population levels were much smaller, but because we developed agriculture, we were able to develop larger communities. Because we were bringing in energy from outside of those communities, we were no longer hunting and gathering. And then of course that has moved forward to the present. So a little bit about carrying capacity. So I'm taking an ecological approach in this presentation today, but I also take that approach in a lot of the things that I think about. And because Bernheim is an organization that is focused in ecology, first of all, a little bit about us. We're more than 16,000 acres. Our mission is to connect people with nature. We operate in 4 big ideas, which is ecological stewardship, connecting people to nature. And in the recent years, we've added actions beyond our borders. So we no longer think of Bernheim as a place, we think of it as a philosophy and thought leadership. But that ecological approach kind of frames much of our work. So we live within a carrying capacity, and in general, we can't go above that carrying capacity. We can do things to extend it, and we have as human cultures over time, like agriculture extended it, and technologies extended it, and future, who knows where that's going to go. But every time we extend our carrying capacity through one strategy or another, there's a cost somewhere within the system. And often we will call those costs externalities. So if we're building a budget, we might budget the labor and the materials and the design and the permitting and all those things. But then we throw the impact to our water and the impact to our atmosphere off of that budget, and we call them externalities. But there are no externalities. That's a fiction. That's just a poor way of conceiving of our impact. So economy and ecology are very similar words. They have the same roots, but I suggest that one of the differences between economy and ecology is that in economy, we often think about externalities. In ecology, we don't. Let's take a look at one of those impacts that has happened because of our design choices over the past 2018 years in the case of this graph right here, which comes from NOAA. But this is atmospheric concentrations of global CO2. And you've all seen these graphs. There's this steep rise later in the graph, and without much disagreement at all, this is all associated with anthropogenic fossil fuel, anthropogenic carbon into the atmosphere. I'm going to shift a little bit now and take you to Bernheim, which is south of Louisville, Kentucky by about 25, 30 miles. It's an institution that's been around for 91 years, and we've done a number of things in the recent past to kind of reframe the way that we think about the way we organizationally have relationship with our landscape. So here's our visitor center. The certificate of occupancy on this building was 2007. We were early in this part of the world as a LEED Platinum project. So this building was the first LEED Platinum project in Kentucky, Tennessee, Virginia, West Virginia, a big circle around that Midwest area. There were more of them on the East Coast and the West Coast. But the thing that I want you to notice about this building is that it sits within its ecology. What I'm going to do now is kind of take you on a journey with us at Bernheim as we kind of shift our thinking from this building began conceptually in the year 2000. So this journey of Bernheim moving from sustainable thinking to regenerative thinking. So in my way of thinking about this, sustainability is mostly about being less bad. It's focused on strategy. It's focused on things like buildings. As we move toward the regenerative design end of the spectrum later in this talk, we'll focus more about relationships and networks. So this building does its job. We're learning how to live with this building, and I want to take you a little bit on some of the sustainability strategies that are embedded in this building. So this is the south exposure you're looking at here. This pavilion is part of the building. It's built in 4 main pavilions that are gathered together. You'll notice that it's built like an erector set, so there's beams and columns. We'll get to that in a little bit, but you'll notice that this building, if we were to look at it on the end, would have a geometry that is matched to the solar angles for our latitude and longitude. So the height and the width and the distance out from the building that the eaves jut are tuned so that on the winter solstice sun, at the lowest sun angle for the year, that sun would come into that room and bathe the entire floor that you see there in the lower right. On the summer solstice, with the higher sun angles, we're going to keep that sun out of the room. So that concrete floor in that area that you see in the bottom right is a solar battery. It's a passive solar battery. And then we improved upon that because we fit the building into an area where there were evergreen trees to the north and deciduous trees to the south. The evergreen trees shelter the building in the winter, and the deciduous trees on the south leaf out in the summer and shade the building. And then we also put a living roof on top of this pavilion that helps to insulate it. So these are good sustainability design concepts for this building, but I don't think we can jump into talking about these as regenerative design. So a little bit about that green roof. We planted that green roof, and then there was so much community interest in it that our staff decided that we wanted to get people up to see that roof. We couldn't do that, and so we built a green roof lower to the ground and demonstrated to people what those green roofs look like. And that was a start of a journey for us. We then grew those out, so you can see how green the building site is. There is actually more plant material, more photosynthetic area on the building site post-construction than prior to construction. This building was slipped into an area between those evergreens and the deciduous trees that used to be a picnic area. But this inspired other things. We then learned that there was a great deal of interest in living roofs, which led us to the construction of 12 different study plots Now, these are not exactly analogous to roofs on buildings in urban areas, but they do help us understand what kinds of plants grow and shallow soil mixtures. We can experiment with different types of substrates to grow the plants in. And this led to more and more knowledge, which led to us then moving into Louisville, Kentucky, where we now manage and install the living parts of green roofs on buildings within the urban area. So now that building at Bernheim has a relationship with this urban landscape that's 30 miles away in Louisville. And now we're growing plants on real at altitude roofs where the conditions are very different and we're getting different information. But think of it as a seed, so that living building at Bernheim has seeded other efforts within the community. And now we're starting to build those relationships and those networks, which is starting to move us from sustainability into regenerative thinking. Let's shift gears a little bit and talk about water. So that blue line into the circle there, Bernheim is big, as I mentioned, we're 25 square miles. So that river in Louisville, the Ohio River, is where the water comes from that goes into our visitor center. So this again is in the early 2000s, where we're not thinking about regenerative design. So we're taking our supply from a municipal utility. So that's a lot of energy that is required to get that water all the way from the Ohio and then into its filtration strategies and then pumped all the way out to Bernheim. So what's pumping it out to Bernheim? Fossil fuel is pumping it out to Bernheim. So it comes to Bernheim at a high cost. So that environmentally costly water ends up on our property. So now what? Do we have sustainable options for how to deal with that water? Do we have regenerative options? And so let's kind of examine some of the strategies that we've employed in this building. So here we have an aerial. You can see the green roofs here. And I want to show you some of the site water strategies that we've brought in to think about water on this site. So on the east side of the building, which is at the top of your screen, the water that comes off of the roof is captured into cisterns, rainwater systems, and then those are underground systems, but we can then use that as water for landscape use. On the north side of the building, which is to your left, the water comes off and goes into a French drain well. It's about 12 feet deep and filled with rock. So as the water comes off of the building, it's allowed to quickly enter into the groundwater. On the west side, we have the pond feature, and on the south side, we have captured runoff water. And then because we've created a green space by building this building, we've increased the evapotranspiration, and we also detain rainwater on the roof. So those are all good sustainability strategies. Now I want to talk a little bit about the dark water. So we're in a rural area. We're not hooked up to sewers. So in rural areas, typically you would send water to a septic tank and then to a drain field. All drain fields fail. And then what we license is the acceptable level of failure. But typically a building with lots of humans would add more nitrogen and more waste into an area than would happen in nature. So let's take a look at what we do that kind of increases the sustainability of this. And so we move the water out of the building and into a septic tank where the solids settle out. And then we've added, and this is increases our efficiency here, a peat filtration system. So In the tanks that you see there, there are baffles with peat moss filled with microscopic organisms that then essentially take what we call waste, but it's food for them, and they eat that and change the chemistry of that dark water. We then pipe that dark water over to our nursery area where there is then what would typically be there, which is a drain field. So what we've done is we've added that peat filtration system between the septic tank and the drain field. Then that water by gravity ends up in surface water. We can then move that surface water to other surface waters and then into a garden project. And I'm going to tell you more about this garden project down the road. But for now, suffice it to say, we grow food there. And that food then is storage of water. So those tomatoes and those cucumbers are really ecological containers for water. That then is moved over to our visitor center where we have a cafe and it's used within our cafe. So one thing that a sustainability strategy might talk about is food miles. How far does food move from its source to its where it's consumed by people? We can actually talk about food feet or meters. So we're trying to make that a nice tight little circle. So these loops that we build are ways of thinking about sustainability and regenerative design. But let's not get fooled. It's not a loop. And it's not a loop because the source of some of that water comes from outside of our system. It's that environmentally costly water from the Ohio River. And so our project out here at Bernheim does a lot of things to be respectful of that high cost water and to use it and reuse it and cycle it and protect it and store it and filter it. But I wouldn't call that a regenerative strategy. I would call that a deeply embedded sustainable strategy. So let's look at some other stories here. And one of those stories is the materiality of the building itself. So here we are back at the visitor center and it's wood. And I would like you to focus on the beams and the columns and the siding of this building. So because we were going after LEED, one of the requirements that would help get points, because LEED is a point-driven system, and LEED is the a standard and point-driven system for third-party certification of how green a building might be. So you can become certified, you can get silver, gold, and platinum levels. And one way to do that is to increase the percentage of recycled materials in the building. So let's take a look at this. So when we were building this building and wanting to increase recycled content, we put out the word for material that we might be able to use. And we got an interesting call back from the H.J. Heinz Pickle Company up in Ohio. They had these pickle vats, the big wooden sided vats where they made the juice, the brine solution that went over pickles. And they were transitioning from their wooden vats to stainless steel or some other strategy. And we went up and deconstructed and brought that pickle vat wood back to Kentucky. It was sent to a mill where it was laminated into these beams and columns and then milled into tongue and groove siding for the building where you see those circles. So that's a good story. But in a meeting where we were talking about this, we asked the question, let me back up a second. We found out what kind of wood it was. It's cypress. So cypress is a great building material. It's insect resistant, it's rot resistant, which is why we can use it a second time after the pickle vats. But we asked ourselves the question, are we responsible for that? Are we responsible for the destruction of a cypress swamp more than 100 years ago that was cut down in order to make the pickle vats? Well, we looked at the materials for the lead requirements, and we weren't responsible according to LEED. We were getting high recycled content, but then we're a nature-based organization, so we began asking ourselves, are we responsible for the destruction of a cypress swamp? Are we morally, are we ethically, are we ecologically responsible? Well, maybe not, but we are connected to that decision. And so that's when we decided to see if we could replace that swamp. So here we are back at that feather-like thing where the giant is, and we created a 5-acre cypress tupelo swamp. We went into that area and we planted cypress trees and gum trees, tupelo, and this is an early photograph when we first put these plants in, and now it's grown up, and over time that will replace the loss of the cypress swamp that got taken apart to build the pickle vats, that got taken apart to build our building. So that's looking upstream, in this case literally upstream, but also metaphorically upstream. Let's look downstream. So I mentioned earlier that the building is essentially an erector set. We worked with the architects on this building, which was William McDonough and partners were the conceptual architects, and we worked with architects in Kentucky, Barnett and Bagley architects, to design a building that has a disassembly plan. So this building can come apart. So now we've got a cypress swamp that comes apart to build pickle vats, that comes apart to build a building, that comes apart to build we don't know what in the future. But that's acting more like nature, because nature comes apart. There is no waste in nature. When something dies, the ecology of the landscape returns that cellulose, that lignin, that biomass from one form to a new form, and it's actually regenerative, because now that dead tree is going to create soil that supports the next generation of tree. So in nature, there is no waste. Waste is a fiction. We can't throw things away, because away is usually onto the backs of people with less power. And so it becomes actually a form of violence. We get rid of our waste in ways that cause health concerns for others or impact other people's water and soil and those kinds of things. I'm going to switch gears now and take you across the street from our visitor center to a project which is a garden project. So this project, we actually started and are still working on as a living building challenge project. So LEED is a point-based system. You get enough points, you get into the award categories. The living building challenge is an imperative-based system. So you essentially do it or you don't do it, and it has a different set of requirements. But we've still drawn an area around this, which is the area that we're calling the project and that we're certifying for the Living Building Challenge, and a little bit about that. So biologists and ecologists love islands because islands have kind of clear boundaries, but they don't really. I don't know if you can notice those islands on the right-hand side there, and you may notice or know exactly what that archipelago is, but it's the Galapagos Islands. So biologists like islands because it allows us to kind of think about ecology and connections and those things in a very different way. Now, I'm an evolutionary biologist, and so I'm required by law to put a picture of Darwin in any presentation that I give, but Darwin was actually looking at the relationships between those islands. And he's beginning to define how things flow between those islands, and specifically genetic information. So really, Regenerative design is how do we build those webs? How do we build those connections? How do we establish relationships that have either been severed or that are relationships for opportunity? And that's where all of this design begins to impact an institution, because the more you build those webs, the more you build those networks, the more resilient you are as an organization. And then the more resilient you are, the more powerful you are to enact good within your community, but also the more sustainable you are in terms of your financing and your relationships within the community that then extend to visitation and other aspects of that are benefits of these networks. So back to the Living Building Challenge, most buildings are in that orange area to the left on that left-hand graph, and a high-performing LEED building would start to approach that turnover point where we are being less bad and we start to become positive within those environments that we are working within. So the project that Bernheim is working on is one of these, is the landscape and infrastructure typology. And so all of these boxes over here that are checked off in orange are the things that are the imperatives that we have to think about as we're moving forward on that project. So we're getting closer and closer to regenerative thinking because we're building more and more networks. So now back into this landscape, I want to talk about some of those networks. So let's talk about water. I want to first show you some of well, here's an aerial view. So we take water from the roof. This building existed before the project. So this is a big water collector. So water we can bring off of this roof and through the ground into a cistern that's over here. We can pump water out of the cistern, and we have solar panels that are direct wired to submersible pumps so that when the sun is shining, we have a way to I've lost my pointer. We have a way to move that water. When that cistern overflows, it's a little over 2,000 gallons, so that roof can overwhelm it. Then it comes over here to a little pond that we use for teaching, and then that overflows and it comes into this storage pond. Hold on a second. And then the storage pond can overflow and come around into a filtering wetland. But this filtering wetland also receives, there's drains in the project here and here. And so that filtering wetland is also receiving drainage water from just the surface water. And then once it's in this wetland cell here, it flows into another pond on Bernheim's property, and from that pond onto another one. So before we release that water back into a blue line stream in our community, it is filtered through natural systems. So here's what, here's how we know if we're doing our job right. So this picture is from prior to us doing any work on that garden. So here's these 12 are those raised bed plots that I showed you earlier for studying roof ecology. And then our ecologists went and established 31 1 meter by 1 meter study plots that reach out into the area that we intended to build the garden. So one thing you need to know about this area is that it had been compromised by prior decisions at Bernheim. This was essentially a waste dump for Bernheim. So it had received broken up concrete from old parking areas and some asphalt and all kinds of bad things in the soil, things that we would not do today, but in a prior set of decisions, Bernheim used this area, much like a farm, a large farm would have an area where they store their waste. This is what that was. Now, there wasn't any oils and toxic barrels or anything like that in there, but this was essentially a gray field or a brown field for Bernheim. So when we hit these study plots and studied what was in them and quantified that, we end up with information like this. So this is just, on the left is 3 pages out of that report, and on the right is the summary of our biodiversity and how that changed just over the course of that first year of study. So from 2012 to 2013, which is our first year of operation within that garden, you can see that we're already getting increases in the number of birds and reptiles and amphibians and spiders and insects. Mammals went down, but then let's look at those insect species, and then order by order, we're starting to see that we are bringing more organisms back into the area of the garden because of the project than existed there before. So here is some of that diversity, but let's remember what this also is. This is also a way that genetic information moves around within that system. It's how water moves around within that system. All of those organisms and all of those plants are part of that water solution. This is a diagram of all of that, but it's so complicated that I thought I would just show you some of the strategies here in pictures. So in the upper left, those are the 2 solar panels that feed direct current into a submersible pump, but we also have that hand pump well there. So one of the things that we do with children and other people is we can race. How fast can we move water around? Here's a bladder tank in here and a hose. So we can move water out of that cistern with power or a different type of power, human power, and we can race that. This is that larger pond, which is storage for, I don't know how many gallons of water, but we can always go to that source if we need to. This is the smaller pond. And then this is that a larger part, which is redundant. So let's go back here and I'll show you those. So it comes off of the roof, it goes into the cistern here, the cistern overflows into here, and there's a wetland cell again. But that, we found out that we only had 2,000 some odd gallons of water in storage. And so that's when we added redundancy. So then down out of this photo, we dug a well. So that's out of the project area, which the Living Building Challenge calls, what do they call that? Scale jumping. And so we dug a well that was about 40 feet deep. And the reason we did it off of the project is because under the project site, we have shale. So shale acts like an umbrella. So when water lands in the surface areas, it's shed out of the area. So we went a couple hundred yards away where the entire geology changes to a limestone area. We put 2 additional solar panels up down out of the picture, and then they pump water into this above ground stainless steel cistern, which was actually repurposed from a house that was demolished not far up the road from where we live. And so they were getting rid of this cistern. So now we have an above ground storage of 4,000 gallons of water that then feeds, once it's full, so the pumps only work when the sun is shining. So once that cistern is full, it overflows into the underground cistern and then back into the pond and down. So we've developed these kind of redundant loops. So at any given point in time, if the sun is shining, we can power up more than 7,000 gallons of water to feed that garden, which is all we need. And we can then back that up with those ponds if it isn't what we need. And then that becomes what is turned over to the ecology and to the food systems that we have. Now, another little story, we wanted to reuse materials wherever possible. So here's those raised beds in that garden during construction. The top left is further along than the bottom right. But where did we get the wood? Remember those raised bed study plots where we were looking at green roofs? Once those studies were done, those were disassembled and turned into the raised beds for the edible garden. So nothing is wasted. We're reusing a resource that we already had and reducing costs. Now a little bit about storytelling. So all of this is really not that interesting until we start telling the stories of these projects. So when we have people in the garden, we use this post in the middle of that circle area to create a clock. So we might have a group of students here and we'll tell them, here's a task you have to do to learn about this garden, and you have until this shadow moves from this point to another point. And because we've done our homework, we know about how long that is. So this picture on the right is we're marking out the shadow arc of that clock on the summer solstice. In the upper left, you see one of our gardeners, Cole Alexander. He's building trellises for I think blackberries or raspberries, and we're using, instead of materials that we purchased, we're cutting down exotic species and invasive plants to build those trellises here. I want to shift now and talk about our approach, which is an ignorance-based approach. So we kind of acknowledge from the very beginning that what we don't know exceeds what we do know. And on the surface, approaching things from an ignorance base doesn't sound good, but let me tell you a little bit about that. For one thing, it's true. What we don't know does exceed what we do know. So if you think of this jar as our repository of knowledge, we often think that we know a lot. So think of all those marbles as what we know. And what is between those marbles is what we don't know. So if we have that jar full of marbles and we think it's full, then we are ignoring the fact that we really don't know a lot. In fact, sometimes our jars of knowledge look more like this. So one aspect of an ignorance-based approach is to kind of acknowledge that from the very beginning. So if what we don't know exceeds what we do know, how would you behave? Well, one thing is you could look to nature, because nature is a library of elegant design. And we are still learning how to read those books. But nature is a cruel tester of good design. So if you don't see it, it's possibly something that hasn't been tried, but it's also possibly something that has been tried and failed, which we call extinction. So another aspect of an ignorance-based approach is to think about the way we proceed forward with a project. So often we will think of 3 or 4 ideas and then settle on one of them before we move forward. So think of those circles as ideas, and we've rejected a couple of them and we move one of them forward. So we've put a lot of thought behind it, and probably intelligent thought, but we've also settled on one track forward. So when you settle on one track forward, there's a lot of emphasis on making sure you can prove yourself right. And so there's self-confirming biases involved in that, and we often create evaluations and to figure out why we were right. Another way of working around that all eggs in one basket approach is to have an idea of where you want to go, that goal, but you try 2 or 3 or 4 different ways of getting there. And instead of looking for why you are right, look for why you are wrong. Because if you find out why you were wrong, you actually have something that you can work on. So nature should be that measure. How do we know what we're doing right? We should look to nature, and that's why we did those bio indexing studies on the edible garden. Now I want to jump again. So we've kind of looked down there at one where our visitor center is. We've talked a little bit about our edible garden. All of these things could be a program in and of themselves. I want to now bring you over here to 3, which is a playground. But before I do, I'll point out that we're in whiskey territory. So this is a big whiskey warehouse right here. And across the street from us is Jim Beam. Now, they are also interested in protecting water because essentially when you buy bourbon whiskey, you're buying water. And so water is very important to the ecological, but also the economic health of this area. So now I'm going to take you and close up, and we'll have some questions here. So Tommy, this last section here is if you want to start gathering questions, and if you want to start people that are listening, if you want to start typing in some questions. So we're building this playground. It's just another aspect of this regenerative design, because we acknowledge that the best time to grab an audience and to build passion for some of these things is when they're very young. So we are now building out a 10-acre playground that extends to the east away from that visitor center, and it's in 3 main zones. And what we're looking at here is that experimental approach, where we're not saying we're right, we're not saying we're wrong. We're looking at 4 different types of play that are on a spectrum from directed learning to kind of exploration up in the woods. And we will be studying that. In fact, we have developed research partnerships with the University of Louisville College of Education, School and Human Development. And so we are working with people who are going to be doing research in these areas. This is a new project for us. It's not complete, but here's the materiality of that project. So you won't see any plastics. You won't see any materials or equipment that's been purchased outside of the region. All those things that we're building this playground with come from literally within 5 miles of the project, with a few exceptions. So here's an aerial view of that project under construction. Here's some of the ground shots of us building these platforms for play, if you will. Some more of that. But the type of play that we're aiming at is not play upon things, but play with things. So really everything I'm showing you here is the stage, and that stage gets set with props, and the props are loose parts, materials, things that children can manipulate so that they have some agency over their play environments. But in the process, and because of how we're programming this, we will be slowly talking to these children and engaging them in aspects of regenerative design, but more importantly, we're building relationships within our communities. So this is a big laboratory for play, but it's also a way that we can learn how to help others build playgrounds. So a lot of our partners are actually within urban areas near us, and especially communities that have the least access to healthy places to play in nature. So that's more or less the end there. What I wanted people to get out of this is that regenerative design is thinking about those networks and those connections, and that if you're just thinking about a project, if you're thinking about where you put your stone, to go back to that first slide, and you're not looking far enough, you're not really developing regenerative projects. And so I'll stop there, and Tommy with the American Public Gardens Association has been gathering your questions, if there are any, because I can't see that. And I'll open it up now for conversations. But down there in the lower right is how you would get in contact with me. And I welcome questions from you that we don't get to today by contacting me at that email address there. Tommy, do we have any questions?
Yeah, absolutely. First off, thank you so much, Claude, for this wonderful presentation. We have had a few questions come through, so let me get to the first few, and I'll try to do them in the order in which they came in. If I don't get to them, everyone, I do apologize, but we'll do our best to get them all answered. So Claude, we had a question regarding the peat filtration system. How sustainable is this if everyone decides to use this water filtration strategy? Referring to the controversial use of peat moss, which is a whole other topic.
That's a great question, and the answer is not very. And so when we were exploring this, we knew a little bit about that controversy, and we're learning more about it. So the answer is not very, and it's a great question. We do believe, though, that because of where we are located and how we operate as an organization, that we can talk about that controversy as we move forward. So I don't want to fool myself or anyone into thinking that we don't make mistakes. There was another huge mistake we made in this project, in that when we, or the visitor center project, when we got the pickle vat wood from the Heinz company, we sent it to a mill in Winchester, Kentucky, and it was milled into the columns and beams and the siding. But it was also impregnated with lots of salt because of what it was doing prior to our use. And we probably should have figured out, or the mill should have figured out, that when you use metal equipment to saw salt embedded wood, that there were going to be problems. So that's that experimental approach where you don't try one thing, you try three things, and you don't look for where you were right, you look for where you were wrong. And then you export your failures as much as you export your successes to open up a dialogue. And that dialogue around peat is a great question and a great topic to dig into, and there are probably far better ways to filter water, but we did that with knowledge at a time that is different than the knowledge we have now. So great question.
Thanks, Claude. So the next question is, what do you do if the sun is not shining? Can the solar panels store the sun to be used on cloudy and rainy days?
So I didn't point out, we do have, let me see if I can go back here. We do have a bunch of solar panels in the project that, here we go. This building over here has 16 solar panels, and they are grid tied. So they are shoving energy into a grid because we were already connected to the grid. And we have a meter in an area over here which measures how much energy we're pulling out of the grid and how much energy we're putting into the grid. And we are putting an order of magnitude more energy into the grid than we pull out of it. There's not a lot of electrical use in this garden. These electric panels here do not store energy. They are direct current to a pump down in this cistern. And so that pump only works when the sun is shining. But let's remember what we need it to do. We need to move water into a garden. So typically, if the sun is not shining, we don't need to move that water. It's either nighttime and we're not working, or it's a cloudy, rainy day and it's raining. The same would be true for those panels that are further down out of the project there. So no storage from these panels in the garden, and then these store through a grid-tied strategy. Another good question, thank you.
All right. This was somewhat related to that question, Claude. It was from earlier. I think it's referring to the visitor center building that you were talking about in your presentation. Is the building entirely heated and cooled by a passive solar system, or do you have supplemental energy used for climate control?
Great question. And there's multiple strategies. So first of all, there is a geothermal field that is sized in excess of the capacity needs for the building. So that's a ground loop where the fluids flow down into the ground and then buffer the amount of energy needed to heat and cool the building. But the other thing about the building, let's see, is that it's built like a big screened in porch. Let's see, there. So there's, inside this room, these are doors that open up. So on the shoulder seasons, when it's fall and spring, the building can open up and we're not heating and cooling, or we're not heating as cooling as much. So between the geothermal loop and the active and passive solar going on here, and then highly efficient materials. Another thing that we do is from the delivery, which is the air handling units, to the furthest reach of the building, those are super insulated so that we're not losing energy as we move air through the building. And then there's also transoms up in this upper layer, fans that move the air. So we reduced the amount of energy needed to drive this building by, I think it was 48% over a building that was modeled according to kind of traditional architecture, which is kind of the way LEED worked back in 2005. You build your building and kind of model the energy, and then you build a dummy building that would be built according to a standard architecture to measure it against. Not a perfect system, but it gives you an idea of how efficient you're making your decisions.
Yeah, more and more questions are coming in here, Claude. We had one earlier that was about what do you do with the human-generated packaging waste that comes from the cafe?
Recycling. So that again would be not a regenerative strategy, right? That would be a sustainable strategy. So the other thing that we do, and we have really good cafe managers, is they make really good purchasing choices to purchase materials that are either fully recyclable or we reduce packaging entirely. We don't sell any water. We have those water fountains where you fill up your own container. And then there's not a lot of packaging of the raw materials because it's coming from the garden. Now, some things come from outside of our food shed, and we make careful choices with the suppliers of those for packaging and those kinds of things. So I hope that answered the question, at least partially. But again, that's a sustainable strategy and not a regenerative strategy. So a regenerative strategy would be there is no waste, or everything is a nutrient to the system, like nature, like those pictures of the dead trees or the tree in the process of dying.
Based on that answer, Claude, I think I can combine two questions that came on. One came in, does Bernheim have a relationship with any of the many human ecological institutes around the country? And then there was a question about what are some references for learning about regenerative design as the next step beyond sustainable design?
Yes, we have relationships with lots of different organizations. Now, whether there's a specific one that the questioner was asking about. I don't know. But yes, so what is a relationship? So first of all, communication is a relationship. Sponsorship is a relationship. Working with organizations toward a common goal is a relationship. So mostly we're focused regionally, but we do have relationships with national and international human ecology organizations. And the second question was,
Second question, it was about how do you move beyond sustainable design into regenerative design? Do you have some resources that have been helpful to you?
Oh, so many. So it's not difficult to kind of dig in and research this area. So it's a process for us, right? So we started, well, I mean, I showed you that dump area at Bernheim. So we're 91 years old. 91 years ago, the word sustainability wasn't on the lips of any staff person at Bernheim. 20 years ago, when we started building the visitor center, that's when we first found out about LEED. So that's when we went to our community and said, hey, we want to build a building. We want to build a LEED Platinum building. And every funder that we went to said, what's LEED? Today, that probably wouldn't happen. I mean, a few people would still ask questions. So the U.S. Green Building Council has a lot of resources. The Living Futures Institute, which runs the Living Building Challenge, they have a ton of resources. And then there are countless books. And if that questioner wants to get in touch with me, I'll be glad to go into the details. But I still think some of the best sources are ecology texts, because until you have a firm understanding of your local ecology and how it works, you have a hard time understanding of how you will build a relationship with that ecology. So I advocate for landscape firms and architectural firms and engineering firms to have on staff an ecologist who is especially adept at working and talking about built systems. So I think job number one, it depends on who you are and what your work is, but I think job number one is to build or hire that basic understanding of ecology.
I think we got a few specific questions related to some of your slides, Claude. One was, I'm curious to know, what is the surface material underneath the raised garden beds within each petal? Do you know what they might be referencing there?
Just soil. We don't have anything. If I'm hearing the question right, and I'm sorry for sliding to all these photos. It's the only way I have to do it.
I think it's.
So nothing. Mm-hmm. Earth. So those are just bottomless boxes with connections to the site soil. And then you'll see that those stone beds make a ring in the center. That's limestone fieldstone. So the farmers in our area, we live in karst topography. So it's an area where farmers are constantly clearing their fields of stone that appears after plowing. So let's ignore the fact of whether or not constant plowing is the right way to do agriculture. Regardless, they end up with piles of what they call waste stone. And so that stone was used to, we gathered. And when you gather it for a Living Building Challenge project, you need to know what the carbon footprint is. I also need to know what the carbon footprint is of this steel structure, this arbor back here. So you convert all of the energy knowledge of your materiality and the transportation and the manufacturing and all those things, and you convert it to a carbon equivalent. And then the Living Building Challenge project requires that you then offset that. And there's ways to do it. One way that we did it was that we actually purchased about 1,000 acres of additional land and put a conservation easement on it, which is not an option for very many organizations, right? But it was one that was open to us. So if I'm hearing the question correctly, the question is what's at the bottom of these boxes? And the answer is site soil.
Yeah, I think that's exactly what they're asking about. Thanks, Claude. Few other like technical questions about does the concrete on any of the projects you mentioned today have special qualities?
Yes, the concrete has high fly ash content, local sourcing. So we know where the sand and the lime came from. Concrete has a high cost, so you have to back it out of the project. And it has to come, you know, the further it has to come, the less that cost is. And then the more efficient the supplier is. But we also have high fly ash. So fly ash is the material scrubbed from coal-generated power plants. We're in Kentucky, so guess what our power comes from? So by using what the generating company calls waste, including higher amounts of that waste in the product reduces the environmental cost of it. But another reason that we use concrete is because of accessibility. So another aspect of a Living Building Challenge project is that you're building the project for all people. So I don't know if you can see, but these raised beds are different heights. The reason why is we brought in a community of wheelchair users and we asked them, what would make this garden more accessible for you? And they said, well, raised beds, because we can wheel up adjacent to them and have greater access. Our question, a stupid question, but still our question was, how high? Their answer from their knowledge is wheelchairs are different heights. So that's when we decided to step down. So this bed is the highest, next highest, next highest, next highest. The other thing about this project is that it's a compass. So from here to here is due north. North is up here. And then the other ones are east-west. And so that sets us up for doing experimental projects with youth. But I want to also then show you this. So this raised bed here is one that you can actually roll up underneath, and you can roll up underneath this one as well. Those were put in because when we did have those conversations with wheelchair users, there was this one little boy who said his spine was fused and therefore he couldn't spin around and interact with a garden bed that he was adjacent to. So we built these two beds here and here so that you can actually pull right up underneath them, and then he could do something in these raised beds in front of him as opposed to the side of him. I don't know if I answered the question now that I think about it.
I think you definitely did. You just added some great supplemental information. Let's see. We've got a few more questions that came in. Someone said, did they thought they saw vines on the posts and beams outside the visitor center? Are they meant to provide summer shade, passive cooling?
Yeah. So yes, but that's not all they do. They also add photosynthetic area to the project. We're a botanic garden, so they also add opportunities to talk about vining plants. They also add food sources for pollinators, beauty, which is of course subjective. But yes, and then this is an earlier photo. So the visitor center, that arbor sticking out from the building, is on a 12-foot by 12-foot grid-like system built out of wood. The edible garden has a 12-foot by 12-foot grid system, but it's made out of steel. Why? Well, because we found out after building the visitor center that, you know, that wood has a lifespan, right? So even though it's a wood with longevity, there is a lifespan. So we wanted to have a material for the next project that would, we felt we could, you know, would be a good decision to use steel. We can totally offset the carbon load of that steel. And once we establish an ecology on this arbor, we're not going to have to do anything with it in any foreseeable time frame. But let's go back and talk about that chronological thinking for projects. I think we do need to think, instead of 10 years down the road or 20 years down the road or even 100 years down the road, we need to be thinking, you know, longer than that. So to answer the question, yes, plus more.
Let's see here. We only have this may be one of the last questions here, Claude. Has the need to reduce packaging influenced your suppliers?
Great question. You know, I can say yes, because we do know of at least one supplier that made different choices after we had conversations with them. Now, does it impact all of them? Probably not. But the more people that ask those kinds of questions, then the more likely that any one person is going to impact that. And that's also the value of collective action, where a bunch of purchasers gather together to increase the collective power of their purchasing decisions. And I think that has a higher probability of impacting supply chains.
All right. Well, from what I'm seeing in the chats, I think you've answered all the questions, Claude. There was one final question about how was this all funded, and they are really amazed at all you've been able to accomplish at Bernheim. I don't know if you want to answer that one.
It's a complicated question. We have a really great director, Dr. Mark Worms, and a development team. And so that's the other value of these projects, is that once you start doing these kinds of things, then you have a different kind of conversation with your potential funding streams. So most of our funding is regional, at least to date, and it comes from you know, members and foundations and grant writing. And to name any one of them, I would be missing hundreds more. So the funding stream is very diverse and spread out. You know, for any one given project, there's large donors and small donors, and then people who have no funding, but then help support us by talking to people who do have funding. So it's across the spectrum, like it is for any nonprofit.
Well, I think it's a good way to close it out. I don't see too many other questions that have come in. I want to thank you again, Claude. This was a great presentation, and I really appreciate you taking all the time to do this, and I appreciate everyone else who's listening that attended today's ELA webinar. So we appreciate the time you took out of your day, and yeah, thanks again, Claude.
Well, I want to thank everybody that took some time to listen to me. I appreciate it. And if you are ever in the area around Louisville, Kentucky, and want to see any of this boots on the ground, please get in touch with me and we'll figure that out. We'd love to host you. Thanks again.